All right. So in this unit, we are going to be looking at how chemicals react. So this is going to be our unit 6. And the things that we are going to be looking at in this chapter is going to be chemical equations, counting atoms and molecules by mass, reaction rates, catalyst, energy, and chemical reactions. Chemical reactions are driven by entropy. Okay. So, but in this specific lesson, I'll be focusing on chemical equations. Okay. So, what is a chemical reaction, first of all? We have seen chemical reaction. We see chemical reactions every day. For example, if you've seen your mom cook food, whatever she's mixing is usually very different from the food that you end up having at the end, right? Because a chemical reaction has occurred. When we look at chemical reactions every day, when we see cars driving, when you drive a car around, a chemical reaction is taking place in the engine of that car. And so there are so many things occurring every day that are classified as chemical reaction. And so during a chemical reaction, one or more new compounds are usually formed as a result of the fact that atoms rearrange. Okay, so if I take an example of the substance that we use every day, which is water. Water is formed when hydrogen, okay, atoms of rare hydrogen combine with atoms of oxygen. So what happened is that the atoms of hydrogen and oxygen, they rearrange to form a product which is called water. So if you look at these atoms and you look at this, you see hydrogen and oxygen are individuals, atoms here at the beginning. But now in water, the hydrogen and oxygen are actually combined. That's what a chemical reaction is all about. And so whatever you have at the beginning of a reaction, we call them reactants. Okay. And what you have at the end of the reaction is a product. So if you are cooking food, whatever ingredients you're mixing, water, salt, and seasonings, and maybe uh, tomatoes and all of that constitute your reactants. And the food that you get at the end is going to be your product. So reactants are always written on the left side of the equation, while products are written on the right side. Okay. So the law of conservation of mass, what it says is that atoms are no atoms are gained or lost during a reaction. So you cannot create an atom. The only thing is that the atoms are going to be rearranged, but they are never going to be lost. Okay. They are never going to be created. They are never going to be destroyed. So the number of atoms that appear before the arrow must be equal to the number after the arrow. Okay. So that is what the law of conservation of matter says. So you cannot create or destroy atoms. Atoms are always the number of atoms, the number and type of each atom is always going to be conserved at the end of the reaction. So let's check this out, right? In total, how many atoms are represented by the following schematic for a chemical reaction? Okay, so if you look at this one here, the total number of atoms here is 6, right? But you have 3 atoms here that are attached to one another. So you have 3 atoms here attached to one another. But in this one, you still have 6 atoms, even though you now have 2 atoms attached to each one another. So we will say that the number of atoms here is conserved. So you had 6 atoms before, you have 6 atoms after. So that is what the law of conservation of matter is all about, okay? Or the law of conservation of mass. It's the same thing, okay? So if you look at the reactants, you have 6. If you look at these reactants, they destroy one another. Not that they destroy, they break the bonds, the links between them. You've learned about covalent bonds or ionic bonds. The bond is a force that is holding the individual atoms together. These atoms, that bond is broken, and so they rearrange, right, to form the new product. Okay. So, so if we look at this reaction, So how do we make sure that the number of atoms at the beginning and the number of atoms at the end, how do we make sure that this number is conserved? When we ensure that the number of atoms at the beginning is the same as the number of atoms at the end, in chemistry, we say the reaction is balanced. Okay, we say the reaction is balanced. Now, imagine that these are the atoms at the beginning of a reaction, and these are the atoms at the end of the reaction. And so the question is this reaction balanced? So what you need to do is that you look at each type of atom, you make sure that the number of each type on the left, again, on the left simply means on the left side of the arrow, and on the right simply means on the right side of the arrow. So if I look at this reaction, I can just tell that this reaction will not be balanced. Why? Because look at these pink atoms. You have two of them on the left, but I don't see any of those pinks on the right. So I don't even need to check the other ones, okay? But just the fact that I have two pink atoms on the left and nothing on the right, it means that this reaction is not balanced. I can go further to look at the blue atoms. Okay, there are two blue atoms on the left, but when I count on the right, how many blue atoms? One, two, three, and four. So that reaction automatic, right, is is such that it is not going to be balanced. Okay. So a reaction that is balanced is one in such a way that the atoms are going to be the same. Now, the only reason, if you want to count the number of atoms, right, you might say, okay, this reaction is balanced. But if you want to focus on the types, then it's not going to be. Because if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So I go to the right and I count one, sorry, I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if I want to go by the number, I will say it's balanced. But very soon you will understand that this reaction in reality, if you want to take into consideration the colors, is not going to be balanced because the number have to be balanced and the type also have to be balanced. Okay. So how many diatomic molecules are represented here? So diatomic simply means two atoms in one. Okay, for example, this is two atoms in one. This is two atoms in one. Okay, and this is two atoms in one. So that's what we call diatomic molecules. Okay, so if you look at the beginning of the reaction, you have two diatomic molecules. Okay, this is diatomic, two atoms in one. So a diatomic molecule is a molecule that has two atoms in one molecule of the element. Okay. But after you only have one. So is the following chemical equation balanced? So that is what I was trying to explain. So now you will realize that when you're trying to balance an equation, you can't just count atoms. You can't just come and you say 1 plus 4, 5, okay, and then plus 2. That gives you 7, okay, times 2. Okay, so you say 5 plus 4, okay, 9. You can't just keep counting like that. What you need to do is that you need to make sure that you identify each type of atom. For example, carbon, this is carbon. An atom of carbon is different from an atom of hydrogen. So how many carbon do I have on the left? How many carbon do I have on the right? How many hydrogen do I have on the left? How many hydrogen do I have on the left? On the right. You need to make that distinction because the atoms are not the same. So if you have two atoms of carbon on the left, you have to make sure that you have two atoms of carbon on the right. Okay. So that's what we mean by an atom is balanced. Now, you have these numbers in front of the formulas. Those numbers are called coefficients. And so what these numbers do is that they multiply everything in the formula. For example, this one multiplies this carbon. Now, in a formula, these numbers are called subscripts. We've learned that already. okay, in the previous unit. And so after carbon, there is no number right here. Directly after carbon, there's no number. So we say there's no subscript. And so if there is no subscript, we consider that there's an invisible one, because a subscript one, we don't write it. Okay. So what I would say is this formula CH4 means that you have one carbon and four hydrogen, because after hydrogen, you have a four. Okay, so that four multiplies this hydrogen. It belongs to that hydrogen alone. And so this number in front multiplies everything in the formula. Okay, so it will be one times carbon, and then it will be one time what? Hydrogen. Okay, and so this two multiplies this oxygen right here. So it will be two times two. So on the left, we will say that there are four oxygen. Now, when you come to the right, which is after the arrow, this 2 multiplies this 2 hydrogen to make 4 hydrogen. And this 2 here multiplies this oxygen to make what? 2 oxygen. And this 1 multiplies this carbon to make 1 carbon. And this 1 here multiplies this oxygen to make 2 oxygen. That's how you check it out. Okay. So is the following chemical reaction balanced? So the question will be yes, because the same atoms appear before and after. You can check. There's one carbon on the left, there's one carbon on the right. Oxygen, how many? 2 times 2, 4. Now you count. 2 times 1, 2, plus 1 times 2. Okay, for oxygen, that's 4. Okay, so if you check hydrogen, there are 4 hydrogen. 2 times 2 here. Okay, that gives me 4. And you have 4 here also. So the reaction is said to be balanced. Okay, so that is that for that section. In our next section, we're going to be looking at counting atoms and molecules by mass.